All right, welcome back. We're looking at Chapter 4 today. We're going to start Chapter 4. And Chapter 4 is going to be our application of derivatives. And what we're going to do is we're going to use those ideas and concepts that we learned about derivatives, but now we're going to start applying them. And some things that we can do are graphing a function. We can look at the increasing, decreasing intervals. We're going to look at some concavity. We're going to be able to sketch a graph without a calculator. Then we're also going to get into some optimization problems toward the end of the chapter. So the first section here is going to deal with increasing and decreasing intervals. Well, what do we know about increasing, decreasing intervals? We've talked about these since Algebra 1, focused a lot of it on Algebra 2 as we talked into our polynomials. But if I have a function here, maybe we have a nice little cubic function, we talk about the increasing and decreasing intervals. And our increasing intervals is where the graph goes from left to right, and it goes in an increasing manner. So the numbers previous, the y value previously to the left, is less than the one as we move forward to the right. So if we take a point here and then a point here, we know that the y value here is going to be less than the y value here. And that's going to be true all the way up until we reach this point up here. And then we go into a decreasing function or decreasing portion of the graph where our values then, our y values are less as we move to the right from the left until we hit this point, and then at that point we start increasing again, something that we've talked about in Algebra 2. Well, now if we look at calculus, what's happening in the calculus of this? And we've talked about these 2 points fairly often at this point in time. We know at these 2 points we have horizontal tangent lines. What do we know about horizontal tangent lines? We know that f prime of x is going to equal 0 at both of these points. We call these points critical points because something's happening there. It's very critical that we know what's happening. Now, what do we know about f prime of x to the left of this critical point here, this first critical point? Well, if we drew in tangent lines, we see that all of these slopes are going to be positive. So we know from negative infinity, all they will call this point A, that f prime of x is going to be greater than 0. From A, and we'll call maybe this point B, if we were to draw in tangent lines, then we know that all of those tangent lines are going to have negative slopes. So between A and B, we know that f prime of x is going to be less than 0. And then from B to infinity, if we were to draw in, again, our tangent lines, we see that all of these slopes are going to be positive. So from B to infinity, we know that f prime of x is going to be greater than 0. Very important as we get into it, and this kind of gets into the critical information that I've provided today. F prime of x is greater than 0. We know that f is increasing on that interval a to b. If we know that f prime of x is less than 0, we know it's going to be decreasing on that interval. And if it's equal to 0, then we know it's going to be constant, then we know we have a critical value. So some things that we're going to look at to be able to find these points. Well, I want you to find those critical points. And where do those critical points occur? Well, they're going to occur when f prime of x equals 0, and that derivative equals 0. One thing that doesn't show up on polynomials, but we will get into with rationals, is also when it's undefined. And we'll talk about that one as we get into rationals. Then we're going to identify some intervals, which we did back in pre-calculus. And we identified a interval chart. We're going to find some test values. We're going to determine the f prime of x sign within those test values. And if it's positive, it's going to be increasing, and negative, it's going to be decreasing. And today we're going to focus mainly on, or actually we're going to focus solely on the polynomials. So we won't get into those rationals until later on. So here's our first example. We have 2/3 x to the third minus x squared minus 12x plus 3. And I'm asking you to find the increasing and decreasing intervals. So the first thing we're going to do is go ahead and find f prime of x. Our derivative here, we're going to multiply our 3 to our 2/3, so we're going to get 2x squared minus 2x minus 12. And what we're going to do is we're going to set that equal to 0. We have a quadratic, so we want to go ahead and solve that quadratic. We can do that by factoring out the GCF first. So we get x squared minus x minus 6 equal to 0. We can go ahead and factor that x squared minus x minus 6. We get x minus 3 and x plus 2 equal to 0. Setting these factors equal to 0, we get x equals 3 and x equals -2. So those are my critical points. That's where something is going to be happening within this function. So what I'm going to do is go ahead and create my interval charts. So my intervals, I'm going to start at -infinity, which is the leftmost point on my graph. And I'm going to come up to my first critical value, which would be -2. I'm going to pick up at -2, and I'm going to go to my next critical value, which is going to be 3. I'm going to continue to do this with all my critical values until I end at infinity. So I'm going to go from -infinity to infinity, stopping at any of my critical points. Then what I want to do is come up with a test value within this region. So I want a number anywhere between -infinity and -2. Anybody can have any of the numbers that you want. -3 works, so we'll use -3. I want to pick a number between -2 and 3, not including these 2 points. Notice I've used the parentheses because it's not inclusive. So I need a number that's in between -2 and 3. Anytime we can use 0, it's a good number to use because it's easy to plug in. And I want a number between 3 and infinity. In this case, I can try 4. And then I'm going to look at the sign, S-I-G-N, of f prime of x. So I'm going to come back up here, and we can use any of these 3 forms of f prime. I like to use the factored form because it's going to show us kind of what our signs are going to look like. We're only interested in what the sign is of f prime of x. We're not really interested in what the actual value is. Because remember, f prime is telling us the slope of the tangent lines. So what I'm going to do is I'm going to take this -3 and plug it in for my x values in f prime. Again, we can do it in any one of these 3 spots. I'm going to put it in here. So that 2 is always positive. So I have a positive 2. If I plug in -3, -3 minus 3, I know it's -6, but I'm really only interested in the sign of it. That's going to be a negative value. If I take -3 and plug it into x plus 2, I'm going to get another negative value. So I'm going to end up with a positive times a negative, which gives me a positive. If I take 0 and plug it in for my x's, again, that 2 is always going to be positive. 0 minus 3, that's a negative value, and 0 plus 2, that's a positive value. So I have a positive times a positive, which is negative. And if I plug in 4, then I get a positive times a positive times a positive. Oh, too many parentheses there. So I get a positive times a positive times a positive, which is a positive. So now I know that I'm increasing on the interval from -infinity to -2. Since it's positive, I'm increasing. If I'm negative, I'm going to be decreasing. So what it says is that the slopes of my tangent lines will be positive in this region. The slopes of the tangent lines will be negative on this interval, and then positive on this interval. So in other words, I can say it's increasing on the intervals -infinity to -2, union 3 to infinity, and we're decreasing on -2 to 3. And that would be a good, nice little answer for us if we're looking for the increasing and decreasing intervals. We can do this with as many problems as you want. I'll give you just a couple more here just to give you a look at what we're looking at. So again, I'm going to find my first derivative. My first derivative is going to be -4/10 x plus 300. You might want to have a calculator out there if you're going to go ahead and divide these out, probably. So if I want to go ahead and factor out a -4 tenths, if I take 300 and divide it by -4, or -4/10, I get, oh, in my parentheses there, I get x minus 750. I'm going to set that equal to 0. So I get the only critical value as being x equals 750, which hopefully makes sense to us since we're looking at a quadratic function to start with. So, and we know that we have a negative value here as our a value. So in our mind, I would hope that we would see that we have a function that's going to be a negative quadratic. So we should only see one critical value, which is going to be that point there. What we've got to do is figure out where that is and make sure and show with the calculus that it's actually going to work. So my intervals, I'm going to go ahead and abbreviate that as ints. I'm going to go from negative infinity to 750, and then 750 to infinity. Again, we only have two intervals since I only have one critical value. I'm going to come up with a test value between negative infinity and 750. Again, anytime we can use that 0, pop it on in there. And then 750 minus infinity, in this case, we can try 800. Again, any of my numbers is going to work. 751 would work for us. We're looking for the sine of f prime of x. So if I plug in 0 again, I'm going to plug it into this factored form. My constant out there, my coefficient of that binomial, that quantity, is going to be a negative. If I plug in 0 here, I get a negative as well. So that tells me it's going to be positive, which again makes sense to me since I know that I'm going to be increasing from negative infinity to this critical value, or this critical point here, which is my 750. So I know I'm increasing there. If I plug in 800, again, that first term is going to be negative. 800 minus a negative, or minus 750 is going to be a positive value. And a negative times a positive gives us negative, so we get a decreasing value. So we're increasing on negative infinity to 750, and we're decreasing on the interval 750 to infinity. All right, ready for one last one? I sure am. All right, so increasing, decreasing again. We're going to find our first derivative. We have a cubic. So again, a cubic, we're probably going to look something like this. So we're going to see maybe, possibly, 2 increasing and then a decreasing. If it was a negative x to the third, we'd see 2 decreasing and 1 increasing. So we get 3x squared minus 6x minus 24. We're going to set that equal to 0. We're going to factor out the 3, so we get x squared minus 2x minus 8 equal to 0. We're going to go ahead and factor this, so we get x minus 4 and x plus 2 equal to 0. So x is going to equal negative 2 and 4. So my intervals are going to be negative infinity to negative 2, negative 2 to 4, and 4 to infinity. And I'm going to go ahead and test some values that are in each of these intervals. So from negative infinity to negative 2, I'm going to test negative 3, negative 2 to 4, there's my 0, and 4 to infinity, I'm going to choose 5. Again, I'm looking for the sine of f prime of x. If I plug in negative 3, again, that 3 is always positive. So I get a positive times a negative. And if I plug in negative 3 there, I get a negative. So I end up with a positive or an increasing interval. If I plug in 0, again, that first term is always positive. I get negative and a positive, which gives me a positive or decreasing interval. If I plug in 5, I get a positive times a positive times a positive, which will be positive for another increasing interval, which, again, as I think about my cubic, that makes sense to me. I have one increasing, then a decreasing, and then an increasing interval. So I'm increasing on negative infinity to negative 2, union 4 to infinity. I'm going to decrease on the interval from negative 2 to 4. And that gives you an introduction of increasing and decreasing intervals with polynomials. Good luck. If you have questions, give me an email and we'll get through it. Good luck.